Okay, so welcome, and today we're going to talk about the graph of a quadratic function. Okay, so in the last series of videos we talked about the quadratic function, quadratic equations, and so now we're going to look at the graph of those. Okay, we're going to talk specifically how do we graph these and what type of graph is this. So let's start with this quadratic equation and let's graph some plots, plot some points to see what this thing looks like. Okay. So if we put in -4 in here, we get 16 minus 8 minus 3. So we get 16 minus 11, which gives us 5. So we get 5 here. And then if we put in -3, we get 9 minus 6, which is 3, which then gives us, negative 6. So 9 minus 6 is 3, which gives us 0. Okay, and so we get -3 comma 0. Okay, so now if we put in -2, what do we get? Well, -2, we get 4, and then we get -4. So those go to 0, we get -3. And then we stick in -1, we get 1 minus 2, which is -1, minus 3, which is -4. And then if we stick in 0, we get -3. We stick in 1, what do we get? We get what? 1 plus 2, which is 3, and then we get 0. And then if we stick in 2, we get 5. Okay? And so if we plot these points, so comma 4, -4 comma 5. So -4 comma 5 is way up here. So let's extend this. So -4 is going to be up here somewhere. Okay? And then -3 comma 0, so -3 comma 0, right there, and then -2, -3, so -2, -3, about right there, and then -1, -4, so we're about right here. Oops. So -1, -4. Right there. And then we got 0, -3. So we're back up here. And then we're at 1, 0. So we're right there. And then we're at 2, 5, which is back up here. So we get something that looks like this. Okay, and so that's what we get for this quadratic equation. And so this is what we call a parabola. Okay, and a parabola is the graph of any quadratic function, like this. Okay, now notice a couple things, that any function, so again, any quadratic function of this type, so let me start with the general form again, like before. Okay, so any quadratic function of the type ax squared plus bx plus c is a parabola. Now, any parabola is going to have this basic shape. Okay, so it could open upward or it could open downward. It could have a maximum point or a minimum point. And all of these characteristics that I'm mentioning depend on the values of A, B, and C. Okay, so now we call these extreme values. or an extreme point. Okay, so if the parabola opens upward like this, then there's always a minimum point, right? So in this case, the minimum point is -1 comma -4, okay, right here. And in this case, the graph, like I said, opens upward. Now, the graph could open downward. If the graph opens downward, then we have a maximum point. So the extreme point is a maximum point, and the graph will open downward. Now, what causes this? Well, actually, the value of A, right? If A is positive, then the graph will open upward, and then we have a minimum point. If A is negative, then the graph opens downward and we have a maximum point. Now the point where this extreme point we call the vertex of the parabola. Okay, so the vertex is the extreme point. Is the extreme point of a parabola. It's either the maximum or minimum value depending on what A is. Okay, whether A is positive or negative. Okay. Let's see here. Okay, so let's do another example. We'll be right back.